Hello everyone, welcome to my U Programming Club. Today we will be solving another daily lead code challenge, and the challenge name is split linked list in parts. So you are given head of a single linked list and an integer k. You have to split the list into k consecutive linked list parts, and the length of each part should be as equal as possible. So no two parts should have a difference more than by one, and this may cause some parts to be null. That's fine for us. The parts should be in the order of occurrence of the input linked list, and the parts occurring earlier should always have a size greater than or equal to the parts occurring later. So return the array of k parts. So what the problem statement mean to say is you will be given let's say a length size linked list. Let's say the name of the linked list is list and its length is length. Then you have to divide this uh, length into k equal parts. So this much number of nodes will be present in each of the k parts. 1, 2, and k parts. And for the if let's say 10 is the length and k is 3. So if you divide 10 by 3, it will be 3. But all the parts will not be having equal number of nodes, because one node will be extra and it will be given to the leftmost node, leftmost part. This part will be given 4, this part will be given 3, and this part will be given 3. So it will be something like this. So how you will be calculating how many parts will be given one extra node, how many parts will have one extra node. Len modulo length of list modulo k. These number of parts will be having one extra node, and these number of equal or say equal parts will be having these number of nodes. At least each of the part will be having this number of nodes at least. So that's the logic. At least every part will have length divided by k number of nodes. At least every part, so you can say every part will have at least k number of nodes. Every part will have uh, len divided by k number of nodes. So each first, how many parts will be having one extra node? It will be len modulo k. So these number of parts will be having one extra node besides this len divided by k, which is equal parts. So it will be more clear to you in the coding part. So it's just that we have to what will be the steps in the algorithm? First, we will calculate the length of list. Second, you will calculate least number of nodes each part will have. Least number of nodes each part will have. Then you will calculate how many parts an extra node, and you will give one extra node starting from leftmost part. You will distribute one extra node starting from leftmost part. So it's a kind of a greedy solution, and time complexity wise it will be order of n, since we will be iterating the whole list only once, and here is the length of the list. And space complexity wise it will be O of 1, since we will not be using any extra space. Let's say this is the list given to you. We will use a current pointer, iterate over the list. One variable, integer variable, size to calculate the size of current part being formed. And two other pointers will be there, or say references. They will be, one will be uh, current head, will be current tail. They will be used to populate the parts in the final result. So that's it. This will be the approach. Now it will be more clear to you in the coding part. Now let's move towards the coding part. This is the first part. We are calculating the length of the linked list. Now this is the result array that we will be returning. This is the array that we will be returning. Now we will calculate least number of each part will have, that is equals, and the number of parts that will have one extra node starting from leftmost part, and that is extras. That's for say references will be used to populate the parts. So till the here the thing to be noted is that equals plus one is the size of the parts which will be having extra nodes. In those parts which will have one extra node. What you will do is once your let's say this current tail from here to here and your current pointer goes from here. Now you will break the link. This link will be broken I hope you are able to understand. Once you are having the end of the part, you will break the link of that part to subsequent parts. I hope you are able to understand. So once you have formed a part from current head to current tail, then you will break its link with subsequent parts or say following parts. So then you will be creating parts which are having a number of nodes. Similar to the above approach, nothing is different here. So at last you will be returning your result. Let's try to submit it once. See, it's getting accepted, and the code will be available in both of the languages, C++ and Java. If you are still having any kind of doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. So thank you for watching. Thanks.